Hey guys, I'm a student major in mathematics and today let's going to learn about the factor theorem. Let's see. And let's see what will we learn today. First, basis of the factor theorem and proof. And then we do some application and exercises. And let's go. First, let's learn about the basis of factor theorem. Okay, let's see the definition of the factor theorem. If ax minus b is a factor of the polynomial fx, if and only if f a over b is equal to 0. Oh, it should be b over a. Let's see why. If fx equal to ax minus b and multiply with qx, let if f b over a equal to 0, what does that mean? It means this factor will be 0, right? Okay, then we can know that ax minus b is a factor of the fx. This theorem was really important and has a relation between the factor of polynomial and the roots, because if we learn that f a is equal to 0, then we can know a is a root of the fx, right? And if we know that f a is equal to 0, then x minus a must be a factor of the fx. It's really useful when solving polynomial equations, and it can easily to help us to find the root. Okay, then let's see an example of this application. Let's see, if we know that fx, then we need to use factor theorem to test whether x minus 2 and x minus 3 are the factors. First, we know that if these two are factors, then the f b over a should be 0. So let's plug these two in this. So in x minus 2, we learn that a is 1, b is 2, and these two, and f2 is equal to 4. 4 minus 10 plus 6 is 0. And a is 1, b is 3, and fb over a in x minus 3 is also 0 too. So fx minus 2 and x minus 3 are the factors of the fx is true, and x equal to 2 and 3 is the root of this equation. Attention! There is an easy mistake to make here. The signal in definition is minus, not plus. So, if x plus 2 is a factor of the polynomial, and the b should be minus 2. The minus is really important. Okay, now you might think why this factor theorem is true. Let's see the proof. In the last class, we learned the remainder theorem, and that's feedback. If fx equal to ax minus b, qx, and the remainder rx, and the remainder will be fb over a, because when fb over a, this factor will be 0 and just remainder with rx. But today, we learn that fx has a factor of ax minus b, and it will not have a remainder. So, the fb over a will be 0, right? That was the proof. And the second way to prove is use long division. let's see an example. Fx equal to, we prove that x minus 2 is a factor. Okay, we learned that if x minus 2 is a factor of this phenomenon, then f b over a should be 0. And in this, b over a will be f2. And we plug it in the equation. Okay, then we can see it will be 0. Then it's true. And use long divisions. Let's see. This application. Factor theorem play an important part in factorized phenomena. We learn that x minus 2 is a factor of gx. Then we use long division. It can be written as this, and x minus 2 is a factor, is true. And we can also find that it can be divided too. It can be divided as x minus 2, x minus 1, and x minus 3. And then next phenomenal equation can be written as the easy way. And then we can find the root. Let x equal to 1, 2, and 3 is the root of this equation when the equation equal to 0. And the second application is root testing. In the root testing, we often find the factor of the constant term and the highest subterm's coefficient. For example, this, we know that 6 is the constant and the 2 is the highest subterm of the x and it was the coefficient. So let's write these two numbers factors. 2 is 1 and 2. 6 is 1, 2, 3, and 6, right? So 6 over 2, the factor, we combine these, we have 1, 2, 3, 6, 1 over 2, and 3 over 2, right? So these numbers, we should try to find the rational roots of the phenomenon. If x equal to 1, then it equal to minus 6, not 0, and we try 2. It will not be 0 too. Okay, let's try maybe minus 2. We find it. X equal to minus 2, then it's a root of this equation. X plus 2 is a factor of the theorem of this equation. And we can use long division again. Okay, then we can find that it was true that hx can be wrote into x plus 2 with, it can also be written as 3. And then we can find the root of the equation. Just use factor theorem to find one root, and then we use long division to find the second and third root. The third application about the factor theorem is phenomenal reduction. Why we show reduction? Because you can see that in this equation the degree is 3, and we often don't like this complex equation. So we like to reduction it into degree 1 and just like this, and it will make us clear. And then these questions we learn that can it be divisible by x minus 2? Use the factor theorem that we need to prove f2 can be 0. Okay, let's try. Okay, we can easily find that it was true. So x minus 2 is a factor of this phenomenon. And then we can use long division again to find the other roots, and we can reduction the phenomenon. Now give you some minutes and you can try by yourself. Okay, then I give you the answers that this complex phenomenon can be written as is, and the degree from 3 we change it into 1 factors, and it was clearly and more easily. Okay, finally we did a difficult exercise. Let's see. This week we learned the complex numbers, and then we learned that 2 minus I is a root of the equation is 0, and we need to find the value of a and the other roots. And if we see the roots, we can think the factor theorem. And let's see. We learned that if 2 minus 1i is a root of the equation, then 2 plus I is also the root. And then use the factor theorem, we can learn that x minus and x minus 2 plus I are the factor of these equations. And then let's try x minus 2 plus I. X minus 2 minus I is a factor of this equation, and we can write it as an easy way. Use the factor theorem that we can find that x squared minus 4x plus 5 is an equation is a factor of this equation. And the next step is use long division to solve this problem. The long division. And from this we can learn that a minus 20 should be equal to minus 32. And then we can find a is equal to minus 12. And then we can write the equation from this to this. And from this, we learned that it have 2 roots. That was. And we can learn that from this, we can know from this factor, we learn that 2 minus n and 2 plus I is the root. And then we should find the root from this. The other 2 factor is minus 2 plus and minus 2i. Okay, this is the last questions of our class. So let's conclusion. By applying the division of phenomena and the factor theorems, we can solve various problems such as finding the roots of a phenomenon or determining its factors. These concepts are helpful tools in algebra calculations and problem solving. I hope you guys can enjoy these lessons and enjoy the factor theorem. Okay, let's see you next week. Bye.